world.
Let's tilt the world. We are going to do a quick lab, and the goal here is to calculate the coefficient of friction between the block and our metal track. First things first, let's go ahead and get the normal force, or force of gravity. It's about 5.5 newtons. So force of gravity is the same thing as the normal force, was 5.5 newtons. Okay. With the track horizontal, find the coefficient static of friction between the block and the track. Do 10 trials or quarter calculations here. Make your notebook look like this. And then we want to line it up with that right there. Okay.
I think you want to use the brown one. Which one's the weak one? Yep, green one, okay.
And let me go ahead and actually put it so they can see on your side, Boykin, okay?
Well, no, that was good enough like that.
Okay
If you hook it from the bottom.
Okay. Come on! Delicate. Okay, here we go. So, watching 1, 2, ooh, around 2, right?
Yeah.
2 that time. 2, oh, that's not trial 1. Trial 1, 2 newtons. Newtons. Trial 2. 2, oh, 2, that was like 1.9.
1.9, yeah.
Okay. Oh.
Okay, when did it first move?
It was right around the 2.
All right.
Right on the 2 for that one. Okay, trial number 4. Oh, that was 1.5.
1.5. They're all over the place.
They're all over the place. Crazy. 1.3 for that one.
Yeah.
Does your guys' data table look like mine? Trial 6. Oh, 1.2 actually, that one, right? I saw 1.2.
That's when it first starts to move.
Yeah, this is crazy. Okay. There we go. Oh. 0.6. 0.5. We'll call it 0.5. Yeah, hold it down there. Here we go. 1 point...
About 1.3.
3, yeah. Like, can't count. My eyes. Okay.
2 more.
There we go. Oh,
About 1.3 again.
1.3. Last one. This is like the best lab we've ever done in terms of efficiency. 1.2.
Yeah, 1.2.
Okay. Now what?
You got to add them up.
Okay. Let's see. 2 plus 1.9 plus 2 plus 1.5 plus 1.3 plus 1.2 plus 0.5, crazy, plus 1.3 plus 1.3 plus 1.2 divided by 10. That's a good thing we took an average, right?
Yeah.
Oh, 2.42. That doesn't make sense. Maybe it does because I had that 0.5 in there.
Nope, that's wrong.
Yeah. 2 plus 1.9 plus 2, 1.5, 1.3, 1.2, 0.5, 1.3, 1.3, 1.2. There we go. That's going to be a bad number. 1.42.
So 1.42.
So force of friction, our average is 1.42 newtons. And we want to calculate the coefficient of friction. Our equation.
How do you solve that for mu?
Solve it for mu. Sound the kitty makes. Do you have something that looks like this?
Bueno.
Great. Our average force of friction was 1.42 newtons divided by our normal force, which was 5.5 newtons. 1.42 divided by 5.5, and we get the force of static friction equals mu equals 0.26.
0.26, that's a coefficient of friction. Cool.
Sweet.
Mission accomplished.
Boom. All right, step 2. Use a pencil to make a mark on the track and place the block. Done that. We're gonna slowly raise one end of the track until the block first moves off the mark, off that blue tape mark. What is the angle of the track? So we're trying to figure out the angle of the track at the point and then make a sketch showing how we did this. Okay.
All right, so let me grab the meter stick.
Go ahead and lift this bad boy up. And the moment it moves, I'm gonna stop it.
Hasn't moved yet?
I saw it move.
Okay, right there. And I'm gonna call that, 0.48 meters.
0.48 meters. Excellent.
So let's make a sketch.
You said 0.48, right?
Yeah, 0.48 meters. And the track, which is the hypotenuse, is 1.22 meters.
Okay, so it says make a sketch, right?
Yeah.
So here's our table. Here's our track. And here's our block. And we are trying to figure out this angle, right?
Yep.
And we know that this C is 1.22 meters. And this is 0.48.
Yep.
Okay, how can we figure out theta?
Now what are the triangle parts that we've got?
We've got the opposite, we've got the hypotenuse.
SOHCAHTOA, which one?
Opposite, hypotenuse, that's sine, right?
Yes, it is.
Okay, so sine -1 of the opposite 0.48, that's an 8, divided by 1.22 sine, there you are, 0.48. I never knew I could be a singer until I became a teacher. And I get 23, we'll call it just 23 degrees.
23 degrees.
So that is right here. All right, next.
Well, we're doing this stuff for them. They need to do it on their own.
What happens to the normal force acting on the block as you raise one end of the track? Huh. So does that mean they should?
What is the normal force?
What is the normal force?
That's a force squeezing the surfaces together.
The squeezage. And when it's right here, the normal force, let me cap this, the normal force and the force of gravity are the same.
Yep.
Anti-parallel, opposite, equal and opposite. But what happens when we raise it? As we raise one end of the track. Well, the normal force is still perpendicular, right?
Yeah, but force of gravity is less.
Uh-huh. So they should write their answer for this question right here, right?
Yep.
Do it. Tell me, what happens? What happens to the normal force? As you, the normal force acting on the block as you raise it up. What force is pulling the block down the track? Well,
show me again.
Well, we know the force of gravity. It has to do with the force of gravity, right?
Yeah.
What component?
Oh yeah, that's right. I remember that component stuff.
What component? What component is parallel to the track? Okay, answer that question. Make a free body diagram showing the forces acting on the block.
So copy this.
Copy that. Do we almost already have that? Or is this a different? We want to recopy this?
Well, they should do this, and this angle will be the one we calculated, 23 degrees. And they need to show the force of gravity, the component parallel to the track, and the component perpendicular to the track.
Got it. So they should start off with it, if they've already got this in their notes. Oh, that's a really big dot.
Big dot's fine. Big dot's fine.
Easy, tiger. Okay, so boom, add in the force of gravity. the force of the component of gravity parallel, component perpendicular. Once you've done that,
calculate what they are.
Yeah. All right.
And we're done.
And we're done. Do it. Make it happen.